Hey guys, what's up? So today I'm going to show you how to factor out any polynomial, and an example of a polynomial is this, and I know it's a fancy word, but in simple terms it's just a way to say any literally combination of terms, right, which usually has an x. -4 can be a polynomial, but pretty much you wouldn't consider it a polynomial because the coefficients of x are all zeros, right? Anyways, so let's say we have this polynomial, 3x squared plus 3x subtract 4, right? And you want to factor it out. Well, most people are going to try finding two numbers that multiply into negative 3 times negative 12, which is 3 times negative 4, and add up to 3, which is right there. You guys can give this a shot. You probably won't find two whole numbers that do this, but you're gonna realize that there should be decimals that do this, right? So when we graph this, you can see that there's 2 points where this term is 0, right? So x subtract a is a negative point, and x subtract b is a positive point. The reason we're gonna do subtraction is because you're gonna see that if a is a negative point, let's call this negative 3, and b is a positive point, let's call this 2. So we'll call this 2 and we'll call this negative 3. You're going to see that x plus 3 is going to have to be 0. So x would have to be negative 3. Negative 1 times negative 3, well, that's plus 3, right? And negative 1 times 2, well, that's subtract 2, right? And x would have to be 2 for this to be 0 when it goes over here. Now, if you were to graph something out like this, it's not gonna be completely the same, right? It may look something like this. It's gonna cross at the same points, but it's gonna be further out from one another, right? And the way to do this is you're gonna have to multiply this whole thing by a. We'll get to that part later on, but okay, so we have that in our mind. How do we find the points where this polynomial becomes 0? Well, a simple way to do it is, let's say you knew the quadratic formula. I'm pretty sure a lot of you guys know the quadratic formula. There was already a video of me explaining it. I mean, I actually don't know it off my mind. I can derive it, but that takes forever, right? So we have negative b plus or minus the square root of b squared subtract 4ac, right, over 2a. So that's our quadratic formula. Now let's look at our polynomial that we have. A is equal to 3, b is equal to 3, and c is equal to negative 4. Correct? Yeah, so let's plug this into our quadratic formula, right? And find the values for where x should be equal to 0, right? So let's plug it in. Negative 3 plus or minus the square root of 9, subtract a negative number, so plus cats, oh come on, okay, plus this 4 times 4 times 3, which is 12 times 4, which I don't know what that equals to, but I have a note next to me that says it's equal to 48. Alright, so we have that, right? So what we're gonna do, we're actually not done. I don't know why I thought I was done, but 2 times 3, right? And now we're finished. So here is our value, right? So when we change the positive and negative signs, right, we get different values for where x should be equal to 0. So let's say you had negative 3 plus, let's add these together, which is 57 over 6, right? If you had plus right here, this is where x needs to be 0. So when x reaches this number right here, you have to do something to the x to make it equal to 0. So in other words, you're going to do x subtract this, right? This part over here. Now let's look at the next part that needs to be equal to 0. negative 3, subtract the square root of 57 over 6. Okay, and this part needs to be 0 when x becomes this term. So what you're gonna do is you're just gonna subtract it by x. Simple as that, right? Well, that's it. That's pretty much what we have. Now, if we plug this in, you're gonna get something that looks like our original function. Let's move the paper up a little. Pretty much, if we plug something like this in, x subtract negative 3 plus the square root of 57 over 6 multiplied by x plus, no, not plus, subtract negative 3 plus, I'm so stupid, subtract 57 over 6. Well, that's it. This is our function right now, multiplied by a, which is a value that we don't know. And this will give us a function that looks similar to this, right? Similar to this first one we have. Now, let's actually plug in the functions and see what we have, right? Okay, so we have our computer right there. This is our original function, right? Where's my mouse? Okay, so this is our original function that's showing in red. And this is the function we just created. And this is me searching a quadratic formula because I forgot it. See, we all have our mistakes or whatever. We all make mistakes, is that what you call it? Okay, so now this is the function we just made, the graph we just made. As you can see, they both intersect at where y is equal to 0, right? So now we need to solve for our variable a, right? So as you can see, since they both intersect at this point, this graph multiplied by this a value should stretch the graph in enough to make, or collapse the graph enough to make it equal to our first graph, right? So let's go back to this. Okay, now, well, let's try solving for 0, right? So let's let x equal 0. So we're gonna let x equal to 0. So we have 3x squared plus 3x, subtract 4. And we have this thing right here, x subtract negative 3 plus square root of 57 over 6 multiplied by x subtract negative 3 subtract the square root of 57 over 6 times a. Okay, we're going to let x equal to 0, so we'll write it right here and solve for it. So x is equal to 0, so that cancels out, that becomes 0, and we have negative 4, right? We're going to let x equal to 0 right here as well, and this should give us negative 4 if we've solved for the variable of a. So this becomes a 0, this becomes a 0, and now we have plus, subtract, plus, right? Okay, so that's what we have. So since we have a negative 1 right here, subtract, we're going to distribute the negative 1, and we get plus 3, subtract the square root of 57, and then we get plus 3 plus the square root of 57 all over 6, right? We multiply it out, and if we multiply this term right here by a, it should give us negative 4. So how do we solve for a? Well, a is going to be equal to negative 4 divided by this thing over here, which is just 3 subtract 57, square root of 57, over 6 multiplied by 3 plus the square root of 57 over 6, okay? And that's our a term. Now, if we plug in our a term, which is this value right here, into our function that we already have, right here, multiplying them all together should give us the exact same function, right? So let's prove it. We're gonna go back right to our graph, and we're gonna plug in our function, which I already copied, which is right there. Now, what I forgot to do is, let's just take out this, wait. Okay, there you go. So I forgot to take that out, but it really doesn't matter. But anyways, as you can see, this is our function in blue. And as you can see, they're all the same, -4, everything, and the original function in red. And as you can see, they are the exact same functions. They're the exact same graphs. Now let's quickly look at why you do subtracting instead of adding. So as you can see, for all of them, I did x, subtract this number, and multiplied by x, subtract this number. So why did I do subtracting, and why didn't I just add them? Okay, so when we use the quadratic formula, let's just write it out, because why not? Negative b plus or minus the square root of b squared, subtract 4ac over 2a, right? So when we do the quadratic formula, this is gonna give us two different numbers, which would usually be a positive and negative, usually, right? I'm pretty sure there would be times where there would be two. Yeah, there would probably have to be times where there would be two positive numbers or two negative numbers, but it doesn't matter. So let's say it gives us two values when we plug in for our negative b. When we plug in for our b, a, and c, it will give us, let's say, values of -2 and positive 4. Okay, if we were to graph this out, you would have a 2 right here, and then you'd have a 4 right there, and it would look something like that, right? Okay, so when x is equal to -2 or 4, this whole function has to become 0, right? Not the whole function. I mean, the y coordinate has to be 0, right? So I hope you understand what I mean. But we have to do something to the x to make it equal to 0. So let's say we have -2. Well, what are you going to do to -2 to make it equal to 0? Well, you're going to add 2, right? And let's say you have 4. Well, what are you going to do to 4 to make it equal to 0? Well, you're going to subtract 4. Okay, so we have adding and subtracting. Now you may be asking, why didn't I just do adding and subtracting? Well, for a reason. Since this gives us two different values, right? -2 plus 4. Let's say we have x right here. When we have -2, we're going to imagine that the x is equal to -2. Well, you're going to have to add 2. And if you have x as 4, well, you're going to have to subtract 4. Now, there was no way of me knowing if this was, other than actually, I would have to actually go in there and solve for it, which I don't want to do because that's a lot of trouble. So instead, I'm just gonna look here. I'm not gonna care what values it gives me. Whenever I put x, subtract, let's say -2, multiplied by x, subtract, let's say 4. It doesn't matter what values these are. I'm not gonna have to care for what symbols I put here or what I do to the x. I can always just make it a subtraction sign, and that's because whenever you have a negative, the two subtraction signs become a positive, right? And when we have a positive and a negative, the two subtraction signs become a negative, right? And that's exactly why, right? So whenever you always put the subtraction sign, no matter what value you get, it makes sure that for that value, it always becomes 0. So when x approaches this value right here, when x becomes -2, -2 subtract -2 equals 0. When we have any value subtracted by any value, any value subtracted by itself will always be equal to 0. And that's exactly why I put the negative sign, right? So it doesn't matter what value this gives us, whenever you have the same value subtracted by the same value, it's always 0. And for that reason, you use a negative sign. Okay, hope you guys enjoyed, and I hope this helped you out. Like I said, if you want to do anything with higher degree polynomials, like a third degree, all you would have to do is use a cubic formula. I don't know if I said this, but you're going to need to use a cubic formula, find all the points where x is equal to 0, and just do x subtracted by all those points, right? and yeah, so on. Okay, so thanks a lot for watching. I hope this helped you out.